Today I want to show you how to factor something out of a polynomial. And to factor something, um, oops, I'm getting ahead of myself here. To factor something means to rewrite an expression as a multiplication. So here's an example. I've got 12x plus 8x. 12x squared plus 8x, that's a polynomial here that's written in standard form. And over here is an equivalent expression, 4x times 3x plus 2. Those things are equal. If I graph them, they give me the same picture. If I plug in numbers, they'll give me the same numbers out each time. But this one is written in factored form. And what I've done is that both of these expressions, 12x squared and 8x, those can both be divided by 4x. And so I factored that 4x out. I pulled it out, and then I wrote here in parentheses what's left. So that's the basic idea of factoring out, is to go from here to here, moving in this direction. It's kind of like undoing multiplication. So before I dive into how to do that, I want to talk a little bit about greatest common factor. If you need a refresher on greatest common factors of numbers, you might want to watch the video on greatest common factors and prime factorizations and things like that, especially the last part of that video talks about greatest common factors. And to find the greatest common factor of monomials, we do two things. We'll look at their coefficients and figure out what do they have in common. So the 140 and the 350 here, what's their greatest common factor? And then we will look at as many variables as they have in common. So xy squared z cubed and x squared y z fourth. What's the most amount of variables that they have in common? What I like to do when I'm finding the greatest common factor is to write out this as its prime factorization in fully expanded form. So 140, if we were to find its prime factorization, 140 is 14 times 10, and 14 is 2 times 7, and 10 is 2 times 5. So as a whole, that's 2 times 7 times 2 times 5. I like to put it in order, so I'll write 2 times 2 times 5 times 7. And then I'll write all the variables out in expanded form as well. So this is a single x. This y squared means y times y. And then z cubed is z times z times z. So there is 140xy squared z cubed in expanded, fully expanded form. Over here, I'll do the same thing with negative 350. Negative 350, the negative sign is just a factor. I'll write that first. And then I'll look at 350. 350 I see as 35 times 10, which is 5 times 7 and 2 times 5. So 2 times 5 times 5, and then times 7. And then the variable part, there's x times x. And then there's a y. And then what's left is z to the fourth power. So I'll write z times z times z times z. Now, the greatest common factor of these two terms is as much as they have in common. What do they have in common? Find it, multiply it all together, and that's the greatest common factor. So I see that they both have a 2 in common. So I'll circle a 2. And I see that they both have a 5 and a 7 in common. So I'll circle a 5 and a 7. And then when I look at the letters, they both have at least an x in common. And they have at least a y in common. And they have at least z to the third power in common. And as a whole, they have 2 times 5 times 7 times x times y times z cubed in common. So the greatest common factor of these two terms is 2 times 5 is 10, times 7 is 70, 70 is the biggest number that divides both 140 and 350. And then the biggest variable part that divides their variable parts together is x, y, z cubed. So this is the greatest common factor. Now, I know I'm getting ahead of myself because I'm probably going to explain it in the next slide, but I can't resist. What's left, what hasn't been circled, is what shows up in the parentheses each time. So, what hadn't been used yet here? We hadn't used the 2, and we hadn't used the y, and so if I write 2y, and then over here, what hasn't been left or used? I haven't used a negative sign or a minus sign. I haven't used a 5 or an x or a z. This here is what I would get if I factored the expression 140xyz cubed minus 350x squared yz to the 4th. So you can kind of check that by multiplying this out. 70xyz cubed times 2y. If you multiply that out, the 2 times 70 is 140. X, y squared, and z to the 3rd. That's this expression. And when I do 70xyz cubed times negative 5xz, that gives me the negative part. 5 times 7 is 350. X times x is x squared, the y, and then z cubed times z is z to the 4th. So that's essentially what factoring out is. Look for the greatest common factor and pull that out, and then in parentheses, write what's left. So, as I mentioned earlier, it's kind of like multiplication backwards, or specifically the distributive property backwards. Instead of distributing something to everybody, we will take out or divide out something from everybody. So notice down here is kind of an answer, a clue as to how things are going to look. Your final answers will always look like this. There'll be the greatest common factor on the outside of the parentheses, and then what's left, what hadn't gotten used in the parentheses. So if we look here at 12x squared and 8x, both of these are divisible by 4, and both of them have an x in common, and that's why 4x was pulled out. And what was left, 3 times 4 times x, the 4x had gotten taken. What was left is 3x. And here this is 4x times 2. And the 4x was taken out, and what was left was a 2. So, in general, to factor something out, I already mentioned this, but find the greatest common factor, and then write in parentheses what's left. You may always check your work by multiplying or by plugging in a number for x or for the other variables, or by graphing, but multiplying it out is a good step to do. So this is the problem I did earlier. So like I said, I got ahead of myself. 140 y squared z cubed minus 350 x squared y z to the 4th. If we go back a few slides, the answer to that is this down here. 70xyz cubed times 2y minus 5xz. So let's see how well my memory is. That was 70 and x, y, z to the 3rd. That's the greatest common factor. And then what was left was a 2x. Sorry, not a 2x, a 2y. And then what was left here is a negative 5, because 5 times 7 gives me 350. I need another x. And I've already got all the y's, and I need another z. So remember, I could check this, but I got a few other examples queued up. Let's look at those instead. So this is the same example we already did too. 12x squared plus 8x. Well, let's show the process, the whole thing. 12x squared, if you were to imagine what is all there, what does this whole thing constitute? There's 2 times 2 times 3. That's how you get 12. 2 times 2 is 4 times 3. And then x times x. And then 8x is 2 times 2 times 2 times x. And what do they have in common? 2's and a single x. 2's and a single x. So the greatest common factor is 2 times 2 times x. That's 4 x's. And what's left is 3x. And what's left here is a 2. So, do you need to write out all this in order to find that? Not necessarily. Some people can do this sort of thinking in their head and imagine it written out. And some people don't even need to imagine it written out necessarily. They just kind of look and they see or they know that 4 is the greatest common number that divides them both. And then they look at the variables parts and they realize that x is the most that they have in common. And they go straight to this 4x. And once they have that, to figure out what's left, they divide. 12x squared divided by 4x is 3x. And 8x divided by 4x, 8 divided by 4 is 2, and x divided by x is no variables. And so that can work too. I do have one other example that's different, the one that we haven't seen yet before. So 21m to the 5th, 15m to the 4th, minus 3m to the 3rd. So I will, when I'm all done, I'll write out everything in case you need to see it written out. But I can see pretty quickly that the biggest number that divides all these things is a 3. That's the greatest common factor. And the biggest variable part that they all have in common is they all have at least m to the 3rd. So the greatest common factor that they all have is 3m to the 3rd. And if you were to divide each of these things by 3m to the 3rd, here 21 divided by 3 is 7, and m to the 5th divided by m to the 3rd is m squared. Remember, you subtract exponents. 15 m to the 4th divided by 3m to the 3rd, 15 over 3 is 5, so I'll put a 5 in there. And m to the 4th divided by m to the 3rd gives us just plain old m. And then here, this one's kind of interesting. 3m to the 3rd divided by 3m to the 3rd. Those kind of essentially cancel themselves out. So you might be tempted to just close the parenthesis and be done. But technically, when you divide the same thing on top and on bottom, that gives you a 1. So 3m cubed divided by 3m cubed is 1. And the fact that it's being subtracted is important. I would want to write a minus 1 here. And we can always check our work by doing the multiplication. 3m cubed times 7m squared, that needs to give us this first term. 3 times 7 is 21. M cubed, m squared is m to the 5th, so that worked out. And then next, 3 times 5 is 15. M cubed times m is m to the 4th, that worked. And if we had been done, if we'd written a parenthesis, we wouldn't get this term at all. But because we wrote this minus 1 here, 3m cubed times negative 1 gives us the negative. 3 times 1 is 3, and the m cubed. And so yeah, this worked out. So thanks for watching, and the last couple minutes is just going to be the same problem, but me writing out all those little factors in case you wanted to see that. So if you don't need to see that, then sign off, and I will see you again next time. This term here, 21m to the 5th, is 3 times 7, and then 5m's. 15m to the 4th is 3 times 5, and then 4m's. And this term here is it's a negative 3 and m to the 3rd, so m times m times m. And if we circle all that they all have in common, they all have a 3. And they all have at least 3 m's in common. So I'll circle m to the 3rd. And that's it for commonalities. So I'll write 3m to the 3rd. And then what's left in this was a 7m squared. And what's left here is a 5m. And here it looks like there's nothing left, but remember there is, even if everything gets used up, you need to indicate it with a 1. But there was a negative sign as well, and so you got to make sure you write a -1 here. And there's our answer.